Diane is from, well, she was born in Queens, New York, and she lived in New York for a large chunk of her life before she headed off to school, to Syracuse, yeah. And that's important that you know this because there will be a test in a few minutes, okay? She got her BS degree from Lemoyne College in Syracuse, New York, then went off to Cornell and got a master's degree in arts of teaching. And then she was a high school teacher for about 4 years, if I added this up correctly. And then she went off to get a PhD in chemical education at the University of Maryland. From there, she went to the Catholic University of America in Washington, D.C., and worked there for 30 years. And the last 2 or 3 years, she's been hopping back and forth between Catholic University of America and the Naval Academy in Annapolis. And she just did her last year there at Annapolis this last time. We tried to get her here last year. It turns out that if you work for the Navy, in order to leave Annapolis and go give a talk, the Secretary of the Navy has to sign your orders. And that turned out to be a real pain in the back end. And so we wound up not being able to do that, unfortunately. She has, among other things, she's been given, has received the Helen Free ACS Award, which is for public service. And in 2012, she won the George Pimentel Award, which is for the most outstanding teacher in that particular year. She has, for chemical educators, she has been the editor or the author or so forth of 3 of the most notable publications in chemical education. This is like the primer's Bible for how you can do chemical education research. So this is required reading for everybody who gets into this field. Now, here comes the quiz, okay? When she was a teenager, Diane participated in an important event. So I'm going to put some pictures up here. I want to see if you can figure out what event she was at. Where? Shea Stadium and the Beatles, right. She went to see the Beatles in Shea Stadium. You're good. In fact, there's the stage where the Beatles were at, and Diane was somewhere in here. In fact, if you look carefully, I went looking for her. Her favorite Beatle, Paul, is picking his nose right here. For those of you who are younger, do you know who the Beatles are? Okay. So, turns out that Diane was in some excellent company. Oh, I need to show you this too. I wanted you to see how much it costs to go see the Beatles. You could buy tickets for $4.50, $5, or $5.75. And her dad picked her up after school, if I remember correctly, drove her out to Shea Stadium and sat in the parking lot, waited for her the concert to be over. So, she was in some good company. One of these 3 young ladies is actually very famous. Let's see if you can figure out who it is.
I don't want to show off.
Anybody recognize any one of these 3? Okay, I'll give you a hint. One of these is a world-famous actress. It's Meryl Streep, right there. And she was at the concert with you.
I didn't know that.
Yeah.
Whoopi Goldberg was there too.
Sorry, who? Whoopi Goldberg was there?
And I didn't meet her either.
But after, this is the second time I've done this to you. I finally, for 4 years, I've been looking for a picture of you. I finally found it.
Oh my God.
It's a picture of Diane. It was after Paul threw her a kiss. This is her right here.
This is helping my credibility, don't you think?
So it's our pleasure to have Diane here with us today, and hope she's going to give a seminar, and I hope everybody has tons of questions to ask afterwards. Okay, so let's got it set up here for you, Diane.
Thank you so much.
That's forward, reverse, and the light is right there.
Yep, I checked that already. So while I'm getting hooked up, why don't we do just kind of a little idea, give me an idea of who's here. So how many people in the audience are graduate students? All right, that's probably about a third. How many are postdocs? That's probably about 10%. How many are professors? Great. How many, any high school teachers? How many administrators? All right, and that pretty much does it. How many are here because they have to be? Okay, that's all right. So here's the idea of this talk, is that a lot of us are being told that we have to do evidence-based teaching and we have to make these changes based upon evidence. But what does that really mean, and how do we do it? I mean, we're not necessarily trained in this kind of field of research, so how do we access it, and what do we do with it? So I'm really trying to concentrate, and we'll give a couple of examples of how to do this. Yell out questions at any time. This is a collaboration between you and me. You have as much right to where this seminar goes as I do. So feel free to bring up questions as they occur to you. So here's some of the problems that I see in the classes that I teach, and I'd like you to think about the problems that you see, either as a teaching assistant or as a professor. The students in large lecture halls can easily mentally check out of class, and they're on their cell phones, or they're just not paying attention, or sometimes they're not even coming. The Naval Academy, they have to come, so I always had a full class. They don't study the notes or read the textbook from one class to the next. It's like, okay, I'll catch up when there's a test, but I don't really have to know that now, I'm too busy. So I'll just keep going to lectures for like 6 weeks, and then I'll take an afternoon and I'll study it and I'll be okay for the test. They're only interested in getting the answer to a question or a good grade. So Naval Academy would say, just show me the mathematical equation, ma'am, and I can get the problem done. And they meant it, because they thought that was the important part, is getting the answer, not necessarily understanding the chemistry or understanding the theory behind it. Or they're solving a word problem in chemistry, and they just don't know how to logically get from one part to the other. So at University of Maryland, when I was a teaching assistant, one of the questions that was on the freshman exam was, what is the density of substance A, whose mass is X, and whose volume is the same as the volume of substance B, whose density is this? And the kids could not do that problem because there were too many numbers. They knew they had 3 variables, D is equal to M over V, but they had 5 numbers. And they could not for the life of them do that because they couldn't logically lay out and analyze what they had and what they had to do. And that continues to be a problem that we see with students. So if these were the top 4 problems that I picked up, anybody want to add at least 2 more problems that they see in classes?
Underprepared in math.
Underprepared in math and therefore can't follow what you're teaching?
The chemistry is harder.
Is harder because they don't know what to do.
Yeah.
P-Chem also suffers from that sometimes. Yep.
Often if they have a question, something they don't understand, they want to just show up to office hour and be told the answer rather than going and trying to figure it out for themselves.
Right, and we're actually going to speak to that point in the second study that I report on. So keep that thought in mind because we will address that. Anyone else? Bored.
And sometimes that's like, it's too easy. If you've had like AP Chem,
Right.
Chem can be like a drag sometimes, or sometimes it's like a teacher problem that they don't bond with the teacher in a way that entertains them.
So if you have a student who in high school took, let's say, honors chemistry and then went into AP chemistry or IB chemistry, and then they come into freshman chemistry because they missed 2 questions to pass out of your class, and now they're there and they know everything. So they are just bored because we're essentially, sometimes we're even using the same textbook they use for AP Chem. So yeah, that gets to be a problem, and that happens at the Naval Academy quite a bit. Anybody else? All right. How many can relate to at least one of the questions we've got on the table? All right, and the others are the bored people? All right, just checking. So that was what we were looking for, any other answers. So where does chemical education research come in? So we're still fighting in the field. The field is maybe 30 years old. And of those 30 years, real research that was using more than, how do the students feel about the new innovation, or doing only t-tests. Really more complicated research has only happened in maybe the past 15 years. And the field is evolving at a pretty fast pace. But its purpose is actually, it comes under this idea of DBER. Have you heard about DBER? Discipline-based educational research. So you have physics education, math education, biology education, chemistry education. All DBER is really meant to start with the problems we see in the class and build a bridge to what we know about how the brain operates. Now, previous to this, we didn't use this cognitive psychology as our theoretical base. We used to say, okay, I used this in my class and it worked. And essentially what our research was doing was generating all these little separate points of light. But as a field, we were not moving ahead because we couldn't build the relationships between these different experiments. When we switched to the cognitive psychology underpinnings for how learning takes place and how the brain is hardwired, we begin to see how one research experiment is actually related to another one. So that's where the chemical education field really started to take off, when we tried to connect teaching and learning to how the brain operates. So DBER research really starts with real problems. They start with the problems that we've been talking about and other problems like this, and they actually try to tie it to what we know about the brain. So why bother with chemical education research? Why should anybody spend their time doing it? Because like any chemical research, and I'm speaking mostly to chemists, I believe. How many are not in chemistry? Okay, so mostly chemists. In any kind of other research, you really don't answer the big questions with a single experiment. You do an experiment and it provides some insight, but it probably leads to 3 other experiments, and that's how you build your professional life. Chemical education research, when it's done well, does the same thing. So we talk about it being well informed and well executed. It may not definitively answer the question you wanted, like, will this make students learn? That's too big a question for one experiment. But you can take learning and you can operationalize that and break it down into components, and your experiment can address 1 or 2 of those components. Learning is a multivariable operation, and most experiments can handle 1 or 2 variables, maybe a covariable. So you're not going to be able to answer a question like, will learning take place, unless you say learning is defined as significantly increasing their score on the ACS exam, or is significantly increasing their score on this type of question on acid-base. So you're going to have to operationalize it, but that's what we do in research, all research. So some things we know about learning. So a lot of people in this room might already know this. This is a very simplistic model of the brain, and cognitive psychologists have gone way beyond this. But if we're starting from step 1, the idea is that the brain has a limited short-term memory. So if you think of the short-term memory as being a table, and there is limited space to how much room you have on this table. In order for learning to take place, the incoming information has to fit on the table, and then the student has to take from long-term memory the information they already knew, and there has to be enough room to integrate them. So if you're giving lectures and you're lecturing for, like we did at the Naval Academy, for 70 minutes straight, all I'm doing is piling more information on the table, and I'm not giving them time to pull back information from long-term memory, and I'm not giving them space and time to do the integration. So if you don't do the integration, the knowledge, the new knowledge, doesn't get moved to long-term memory. Where's it go? It falls off the edge of the table, you can't find it. Here's something else. There is a limited capacity to the short-term memory. Have you ever had a student come to you in office hours and say, I looked at this test question, I never heard you say that? And you think, well, maybe if you stayed awake, you would have, I did say it. They're actually right. They physically did not hear you say it because, even if they were awake, because once you flood the short-term memory, nothing else goes in. It's like a memory buffer in a computer. Everything else falls off. So they literally didn't hear you say it. The only way you can clear the short-term memory is to allow the integration to take place, move everything into long-term memory, allow more information to come in and more integration to take place. Now, this is going to show up in one of the experiments that we've done. So that's why I'm spending some time on it. So experts maximize this use of the limited space by chunking. So that means that they take the information that's coming in and it comes in as a chunk, not as a single factor. But for novices, it comes in as a single factor. So how did they figure this out, these cognitive psychologists? They went to chess playing. And they had a board where the chess pieces were involved on the board in a play. And they had novices sit down at the chessboard and look at the chessboard for 60 seconds. And then they took all the pieces away, and they had the novices replace the pieces. The novices could replace anywhere between 5 and 9 individual pieces, but no more. They had experts do it, and experts could put back 18 pieces. Because for an expert, 4 of them were in a particular chess play. So that was one chunk. It wasn't an individual factor. So that's why experts can actually come to a seminar, let's say in chemistry, and can process the information so quickly because they already have the background. But a novice comes in and they're lost in the first 5 minutes because every factor is new and they're getting overloaded and they can't move it out of their short-term memory buffer. So one thing you can do to offset that limited space is to write things down. That's why notes were invented. If you write things down, you take it out of short-term memory and stabilize it on paper. That's why the students come in and they just want to take notes and then they'll learn it afterwards. So when we go to the flipped classrooms, we stop saying, okay, you're with me, the expert, and all you're going to do is copy down notes, but you're going to do your learning when I'm not around. In the flipped classroom, we say, shouldn't I be there to help you when you're trying to put this together? So let's use that time differently. Use my expertise while you're all here. You know, suppose you went to a doctor and there was something wrong with your foot, and your doctor just wrote down a lot of directions and just handed you the paper and didn't tell you what it meant, and then you go home and you try to figure out what his note said. You should be able to ask questions of the expert while you're there with the expert. So that's what this whole idea of flipped classrooms is based on. It's based upon cognitive psychology. And that's why it's got some legs to it. That's why it's been around for a little bit. So how do we exceed our student short-term memory just in normal teaching? Here are 2 examples. The first example, and there are many, is we provide this continuous stream of new information in a 50-minute lecture. We talk continuously. We overload them, probably in a very short period of time. Or we ask questions or problems. So we give them a problem on stoichiometry, and we throw in all of this extraneous information. And the student who's a novice can't tell the extraneous information from the important information. I'm not saying you shouldn't do problems with extraneous information, but the timing is crucial. You have to give them some experience and some confidence in doing a bare bones experiment or bare bones problem before you give them one that's loaded with a lot of extraneous. Because they have to, it's a different decision process for them. What do they do with the right information versus what is the right information and what is extraneous information? So we're going to take a look at this first one, this cognitive overload. That's what it's called if you try to research it in literature, about what's going on with too much continuous information. So if you would, pick a number. How long can students pay attention in lecture? Typical lectures here are 50 minutes.
12 minutes.
So 50 minutes. So 12 minutes out of 50, 7 minutes out of 50, 5 minutes out of 50. Some of you are just being facetious now. How many believe they can pay attention for about 20 minutes? Okay. How many think they could probably pay attention for 30 out of a 50-minute lecture? Can. Well, let's say can. Can. So if you go back to this cognitive psychology thing about how limited the short-term memory is, that should definitely come to bear with how long they can pay attention. So yes, they get bored. Yes, they don't pay attention. after a while, but that may be because their brain is so saturated they haven't had time to integrate it and move it into long-term memory, so it's just coming and coming and coming, and they've pretty much given up. So that could be part of it. We don't know. So what we did, let's see if I'm up to that part yet. So I've just explained this, that the reason that they have cognitive overload is that there's too much information, not enough space to deal with it. So anything that comes in after the capacity is exceeded just isn't retained. So even though you prepare a well-structured lecture, a lot of people, well, let's say prior to, let's say, the past 10 years, the best chemistry professors were those who were engaging lecturers. But what made a professor engaging? Very often they would do a couple of things. They would relate the chemistry to real world, or they would do demos, or they would do both. They would certainly ask students to do a problem, ask for their responses, give them a chance to try it. So those were all things that differentiated your typical professor from your outstanding professor. Those things haven't gone away. So we still interact with students through demos, and now we also can interact with them through technology like clickers. So how many people have seen, experienced, or used clickers? So they're pretty widespread, I would say, at this point in time. So we actually want to do an experiment to see how long students paid attention in class. So if we had a choice of three populations, engineering students, chemistry and biology majors, our engineering, chemistry, and biology majors were in the same class. Then we had nursing students and we had non-science majors. Who of those three, the science majors, the nursing majors, or the non-science majors, who would pay attention the longest in your estimation? Now you have to vote. Science majors, how many believe it would be science majors? That's not too many. How many say it would be nursing majors? Also not too many. How many say it would be non-science majors? All right, the rest of you who are not voting, what are you doing? Right? That's why we use clickers, to make sure that we know who's not clicking. So we picked those three populations because we wanted to be sure that if there was a difference in the motivation of the student to be in the course and that affected attention, we caught it. So now we're going to have one shot at this, right? We also are going to have to do it over an extended period of time because maybe if the topic is density, everybody pays attention. Maybe if the topic is thermochem, nobody pays attention. So we're going to have to do this over an extended period of time. So we chose 6 weeks. We were going to see how long they could pay attention in these three classes every day of lecture for 6 weeks. But you know what? How are we going to collect the data? So I thought about this for a really long time. So what we did is we issued clickers to the students on a lanyard as they walked in the door. And we said to them, every time your mind drifts, press a button on the lanyard clicker. So if the teachers were using clickers in class, they had two separate clickers and they knew which was the one that measured attention. So that means we had to have two computers in the room, the one the teacher was using if he or she was using clickers and the one that was collecting our data. So our data was being collected in the back of the room. So now how did we correlate that announcement of your mind drifting with what was going on? That was really a difficult bugaboo. What we wound up doing was to run a continuous PowerPoint on our computer that changed its slides every 30 seconds. And it was on a tablet so we could write on it. So the graduate student would get a new PowerPoint, blank PowerPoint, every 30 seconds, and he or she would write what the teacher was doing, lecturing, doing a demo, using a real-world example, interacting with the students, whatever it was, we would write it down. Then we had to integrate the two series. So that took a while. I won't say it was easy, but that's essentially what we did. And then we said, you know, this is so awkward that the students have to remember to click it. We're going to throw out the first 2 weeks of data because they're still getting used to the procedure because we don't want that to interfere with our results. So now we've tried to take into account everything we can think of that could possibly go wrong. Of course, we missed a couple of things, but that worked. So here are our 3 general chemistry classes. So remember this. 1 is engineering majors, 2 is nursing, 3 is non-science majors. So they're in that kind of hierarchy that you might think happened. Clickers I've just talked about. attention data and teaching activity integrated, 6 weeks throughout the first 2 weeks. So what did I just do? I talked to you about what we did, and then I summarized it here. So you have 2 ways of dealing with the overload. If you couldn't follow everything I was saying, the key points are here. So I'm playing to your short-term memory limited capacity, just so you know. So here's what we found out. Now, I'm going to show you a graph on the next slide. There are 3 colors, purple, black, and red. The only one that we were able to say was significantly different from what was expected were the nursing majors, only because they answered the question in a high enough number. The others didn't participate as much as we would have liked. But what's interesting is the general pattern that you see for the 3 classes on the same graph. And these are the peaks in attention lapses. So when you see a peak, that means they're not paying attention. And because these were 3 different classes, we had to find a common length of lecture in all of the 3 classes. So we took 10 minutes, because each of them had at least 10-minute segments of lecture. So here's the graph. And what we find, here are the nursing students, but notice the green panel. So in a 10-minute lecture, within the first half minute, nobody's paying attention. So when you're giving them directions about what you're going to be talking about in the lecture, most people don't hear that. And then they kind of settle down, except for the engineering majors. We're not really sure what's going on with them, but I have an idea. I'll tell you about that in a minute. Between 4.5 and 5.5, that's where we have a lot of attention lapses. And then we have another kind of high point between 7 and 8, and then in the last minute of the lecture, nobody hears. So when you're summing up and getting in that last bit of information at the end of the lecture, nobody hears it. So what's interesting about this is that the patterns are eerily the same in terms of their peaks. So if you think about this, this could actually be attached or connected to how the brain is hardwired. It may not be that they're equally lazy at the same time. It could be that they actually drift from paying attention to the lecture while they're trying to integrate that new knowledge with the old knowledge. So that this is a hardwiring issue. Now, prior to this, the only experiment that had been done this way was with somebody, a team, sitting in the front of the lecture here, looking at the people in the audience and looking at their eyes and taking a look at how long they paid attention by looking at whether their eyes were focused or not. And they were so good that their data actually mimics ours, or ours mimics theirs, however you want to put it. But so I'm really beginning to have some confidence in this. So this gave us something to work with. Go ahead. The error bars. I don't remember that off the top of my head, because this was 2010, and we did the data in 2009, but I can look it up.
I'm just curious if it's bigger or smaller than the swings that you see.
Oh, it's smaller. Yeah. That I can tell you. So we didn't stop here. Go ahead.
Oh, sorry. I was wondering if you interviewed the faculty at all to see if their behavior changed, because if I looked up and I saw a bunch of people clicking this button, I'd be like, oh no, I better try and engage them in a different way, or change, stop for a minute and do something different. I was wondering if the faculty had any feedback, or were they told to strictly just keep doing
We told them just to keep on doing what they normally do. And to tell you the truth, it was a lecture hall that seated 350, and none of these classes had anywhere near that. So the kids were spread out all over. And because it rose up on a high, steep level, you couldn't necessarily see the student pressing the buttons on the lanyard.
Related to that a little bit, I was wondering about controls and how, telling the students, click it when your mind drifts, is that influencing their attention?
It certainly could. That's why we did it for such a long period of time. We did believe that it would influence them in the first 2 weeks. That's why we threw out the attention. It's kind of like the Hawthorne effect. They're expecting that they're being measured, they want to do it right. And after that, once they had gotten used to the routine of it, we felt that was our best chance of getting good data that wasn't influenced by that. So we went further with this. This was only a 10-minute lecture. We then followed up by doing the same sort of thing when people did a 10-minute demo. And we compared and contrasted, because not all of the faculty did demos. We compared and contrasted with when the teacher did a 10-minute clicker experience, where they asked a question, the students discussed it, then they came back and discussed the results as a whole. So we had 10-minute segments of lecture, initial lecture, 10-minute segments of demo, 10-minute segments of clicker question instead of demo, and then a second 10-minute lecture. So we wanted to know, was there any difference in the amount of attention waning, or attention, how would I say that? Decline of attention when they had demos. So yes, so they paid significantly more attention in the 10 minutes of demo than they did in this first lecture. They also spent significantly more attention during a 10-minute clicker interaction than they did during this first 10 minutes. And there was no significant difference between either demo or clicker, which I have on the next slide. So doing any kind of, either one of those two interactions for 10 minutes improved their attention. What about the lecture after either the demo or the clickers? It had significantly fewer attention lapses than the first 10-minute lecture. So if you think about this, suppose in a 50-minute lecture you did 2 clicker questions. You could improve their attention span for the entire 50 minutes by breaking it up with just 2 clicker questions or a clicker and a demo, or something else. It doesn't have to be a major overhaul of what you do. You can dip your toe into this active learning and still see significant results. Question?
Was your study on the demonstration effect in the same publication?
Yes. So it is one publication, yes. So here's the comparison of the initial 10-minute lecture to the second 10-minute lecture after a demo or a clicker question. So there are significantly fewer attention lapses compared to the initial lecture for the 2 non-lecture components. There's no significant difference in effect on lecture between the interactive pedagogies with each other. So you got a lot for that one 10-minute interaction. So again, this is going back to how the brain is hardwired, which is why this kind of research gets cited a lot, because it's not just an independent little, this is what I did in my classroom, but it's tied to what we know about how the brain operates. And it gets away from this idea that the student is at fault and they're being lazy. So one of the books that Butch put up there was the book about myths. So that would fit into this definition of a myth. The students are lazy. They're lazier now than they were when I was in school. I mean, what we're really talking about is probably the hardwiring of the brain, that they don't have the ability to change. We don't have the ability to change.
So do you know how long that kind of break for the demo or the clicker has to be effective? Like if you just do like a 2-minute like think, pair, share, is that like enough to kind of like reset them to be ready, or does it have to be 5 or 7?
So that I don't know. But as I said in the beginning, one experiment usually opens up to even more questions. We did it, we kept the 10-minute time frame the same. What was interesting, remember that extra blip on the engineering students? That extra time of attention lapses? So we thought, the engineering students came with laptops. Like, this is 2009. Of course they're serious. When you sit in the back of the room and you see what they're watching on their laptops, they all were watching full-length feature movies. So it probably was a dull part in the movie. What can I say? So it wasn't as if they were paying more attention than the other groups. So that was a myth, that they would be serious about chemistry and the others wouldn't be. So theoretical reason, students have time to integrate new knowledge with stored knowledge and short-term memory during the break in lecture. You're not just saying, okay, just now go and think, let's all be quiet and have think time. You're actually engaging them in the same information a second time around using a different vehicle. So it is rehearsal. That also is, part of what we know about cognitive psychology, that rehearsal is needed. And it is giving them time to do integration, because the amount of information, if you do a demo well, is not going to be overwhelming. The amount of information that they're just looking at in a clicker question is not going to be overwhelming because they're engaged. So how can we engage students in lecture? How do we take this research and pull it into our lecture? So provide opportunities for the audience to engage with the material. That can be newfangled stuff, like flipped classrooms. It can be technology stuff like clickers. It can be more traditional stuff like demos. Now, not all demos are the same, and not all clicker questions are the same, but that's the second generation. But working on problems, just say, okay, I've given you this. Turn to your partner, work on the problem, and then either use technology to have them all send the answers to the podium where you can put up the answers of all the groups, or just have them report out the answer on clickers, or find a way where they have to actually put their ego, attach their ego to a question. So if I said to you when you came in here, I'm going to be at the door here, and I'm going to ask you, what was the best thing you liked about this seminar when you leave? You're going to pay a little bit more attention than it's a regular seminar, and you just say, oh, that was nice, and you go. You know, and you've been thinking about what you're doing Friday night. And not that I'm against Friday night plans, but, you know, this is Tuesday. So again, it's cognitive psychology that is the underpinnings that leads to the research and that gives the results legs, that you actually can do more with it. So what other types of questions can chemical education research address? So going to the Naval Academy, we have 1,000 students who take general chemistry. They all take the same course. They have 28 different instructors. We have a syllabus that we have to cover. Everyone covers the same syllabus every week. You have the same labs. Teachers teach the lecture in the labs. There are no teaching assistants. We do all the grading. We're in with our students all the time because the main emphasis of the Naval Academy is teaching. As an institution, it is teaching. Same textbook, same syllabus. They take common exams at 6 weeks, 12 weeks, and the final exam. What are these common exams? The 6-week and the 12-week are 25 multiple choice questions. They're on the par with the ACS exam. Where do they get the questions from? They have a data bank of 2,000 questions. They'll draw a certain amount of questions from the data bank, and they'll write new questions each year. The committee will write it. But then they will check all of the statistics on those questions to make sure that it is doing the same breadth and the same depth and the same level of complexity every year. Because the Secretary of the Navy said that 1,000 students will take general chemistry and 1,000 students will be successful. So we make that happen. So we're not going to give them a test where the average is 20. So the tests are really well thought out and well planned, and then they're circulated among certain members of the faculty beforehand. So they've done, having worked on the Exam Institute for ACS, they're done really well. I have to admit that. But then in addition to those 2 common exams, the instructors can write 2 exams at sort of in the first 4 weeks of the course, and then at 16 weeks. And their tests can be anything. They can be multiple choice, they can be solve problems, they can be essays, they can be partial credit. So you've got 2 different kinds of exams. So what we wanted to do with the Naval Academy people is listen to what were concerns for them. So the Naval Academy people have put out this plethora of student support systems. So they have, professors are going to love this, they have supplementary instruction on demand. It's called EI, extra instruction. So a student leaves your class and says, excuse me, sir, or ma'am, I'd like to meet with you today because I didn't understand what you did in lecture. When can you meet today? And you look at your schedule and say, I have like 45 minutes the entire day. And the mid says, okay, I'll meet you then. And you don't say no. So you have EI on demand. If you teach 40 students, you could have 40 EI sessions. That's how it's done. The teachers come in and run review sessions before these common exams if they want at night, because the mids are only free from like 8 to 11. So no matter how far away from the Naval Academy you live, you come in at 8 o'clock and you run a session if you so choose. They have a resource room where the faculty are assigned an hour, where you are in the resource room for 1 hour a week. It's staffed from 8:30 in the morning till 3:30 in the afternoon by chemistry faculty, and you answer any chemistry question from any chemistry course that is taught in the department. They also have their online homework is posted for them to look at. They have the upperclassmen who run sessions at night on review. They all live in the same dorm. They live in companies, so there are people of all different levels in their company, so they can go to anybody in their company for help. They also have an academic center that provides remedial classes and tutoring groups and personal tutors free. So there are tons of things they can go to. They have a textbook, they have an ebook of that textbook. They have the printed review from the textbook, the study guide that goes with it. So the Naval Academy spares no expense to get them what they need to be successful, because remember what I said about the Secretary of the Navy. They do have to be successful. So we're running our faculty into the ground. So when I came there, I said, well, let's take a look at what's being used and how effective it is. Maybe we don't need all these things. Maybe we could put our energy into a few. And they're kind of like that. So here's our population. 1,015 freshmen enrolled in general chemistry for science majors in fall of 2013. 28 different instructors, each teach 2 to 3 sections of lecture and lab, 20 students per section, no teaching assignment. Course design, 1 syllabus, 1 textbook, common multiple choice exams at 6 weeks, 12 weeks, and final. Remember what I just said. If you didn't follow what I was saying orally, here are the salient points. No time in class to address the learning needs. I once, in a 70-minute lecture, and I'm not proud of this, went through 8 different kinds of mathematical problems. Didn't matter if they fell asleep. I had covered it. Navy said I was clear. So the lecture is nonstop. So if a student has a problem, you don't have time in class to address it very much. So you're on a relentless race. You'd cover probably about 30 pages of the textbook per lecture. And you have to. If you don't, then they won't be able to do the lab that week, or they will be behind when it comes to the common exam. They have the printed midshipman schedule on their website. Shows that they have from 8 until 11 every night to study. They go to class, they're up at 5:30 for Reveille. They go to class from 8:30 to 4. Then they have so many hours of military marching and stuff. See, I'm not military. And then they all have to go to dinner together. And then they have to meet with their companies. And then they can go to the library from 8 to 11. And then, or they play sports. Everybody has to do 3 hours of physical activity every day. And then lights out. So there's not a whole lot of room. And sometimes they come late to class because they're marching watch. And so they have all of those other military activities. So money students succeed because they have good test-taking skills. They know how to take tests. They've been taking tests all of their lives. But for the military, it's really important. They have really great math ability. Their SATs are pretty good. And they know how to memorize, because as a plebe, they have to memorize the daily menu. And an upperclassman can stop them at any point during the day and ask for the menu, and they have to recite it from memory, and if not, they have to drop and do 60 push-ups. So yes, they memorize every day. But their deep understanding of chemistry, even if they're getting A's in the course, is not always evident, and that was really bothering the chemistry faculty. So here are the current resources that we've got. Help on demand from the instructor outside of class, resource room staffed by instructors, upperclassmen run sessions, prior common exams. So the common exams are actually posted on the departmental website from the previous year with the answer key. I didn't turn off my telephone. That's my sister. I'm not answering it. I'm busy. Online homework is available. College-wide academic center. So here's just everything that they've got that they can use. So our research question was, how can teachers encourage deeper understanding versus memorization? Because that's what they're getting by on. They're getting by on their math skills and memorization. Do the learning resources used by students and the way they use them foster understanding or memorization? Because maybe we're our own worst enemy. Maybe we're just providing resources where we teach them how to memorize better. So we took that research question, we broke it down, and the smaller questions is we wanted to know what the students were actually doing. Now, I know that all the colleges and universities have this big push on assessment, so you get numbers. Well, we didn't want to just say 8 people accessed this from the web today. We wanted to look at this deeper than that. So we wanted to know if the students matched their resource to the type of test they were taking. Remember, we had multiple choice only, and then the instructor exams. Was there a difference among students of different achievement levels in the resources they chose? Did the AB students choose the same thing that the DF students did? And then how did students use the resource they chose? So the proposed outcome was that we thought we could help teachers determine what they could do to help the students emphasize understanding and which study resources were primarily used by which group of students. So we had 5 chemistry instructors who became part of our research team, because you don't really do research to a department. You do research within a department to help them answer the questions that are of importance to them. And even if the faculty members of the chemistry department do not know all the ins and outs of chemical education research, they are full partners in the team. So it was like putting together a group for an NSF grant. You bring in a crystallographer, you bring in somebody who knows NMR, you bring in all the different specializations. We wanted the same thing in our research team, and what I brought in was the chemical education research know-how. One of the results of this research was trying to actually train the faculty to be able to research their own questions after I left. So what we did here was to develop a survey that we administered to the 1,000 students 4 times during the year, once after each of those 4 exams, the 2 common and the 2 instructor. And we asked students what resource they used. We said, list all the resources you use. Here's a list of what you got available. List all the ones you use. And then we did another question that was open-ended. We said, what is your main study resource? We did that because we wanted to hear it in their own words. We then had 57 out of these students come in for interviews after the 3rd survey, and we asked them to describe not only the resource they used, but how they used it. We did that for 2 reasons. We wanted to be sure that we were interpreting the data from the surveys correctly, that when we said EI, extra instructor help, that the students, when they saw that on the survey, interpreted it the same way we meant it. So we were validating the survey, but we also wanted to expand our interpretation of the results. So we chose this the 57. We tried to make sure that we had A, B, C, D, F students. Sometimes that worked, sometimes it didn't. So here's some of the data. Now, obviously, I made it really small so nobody would ask me really hard questions. But you can still see the trends. So let's look here. The 6-week common exam, that's right here, and the 12-week common exam. And you see that the major resource that was used was the prior assessment. That means the answers to the multiple choice questions from the previous year. So all in all, the students reported 46.4% used that as their main study approach for the 6-week exam. 54.3% used those old exams as their main resource for the 12-week exam. Okay, that's good. That's what they were told to do. That made sense. When you go to the instructor exam, the main category is purple. That was notes. So when they study for the first instructor exam, yeah, some of them are still using the prior assessment multiple choice, but now you've got 41% who are using notes, and you have 35.9% at the end who are using notes. So they did switch. We learned 2 things from this data collection. They do, for the most part, match the resource they use to the type of test they have. That's a good thing. And it is fairly stable over the semester. There's a little bit of movement, but it's fairly stable over the semester. So do students match the resource used to the type of test? That was our research question. Yes. They choose different learning resources depending upon the type of exam. So for the instructor written exam, they used notes, prior assessment, and personal help in that order. Notes was their first and foremost. For the common exams, they used prior assessment, notes, and personal help. Same 3, but they used prior assessments more often. But we're still looking at this in general. We're still looking at the large number of students. So there's a lot of wiggle room here. Numbers can lie. Correct me if I'm wrong. Numbers can lie. Actually, interpretation of numbers can be off base. So we wanted to go beyond this. We know that the pattern appears stable, but we wanted it to go further. So what we did is we looked at what grade they got at the end of the semester and then went back and reanalyzed the data. So these are the course grades that they earned that put them into these categories, A, B, C, and D, F. There are no pluses and minuses at the Naval Academy, so it's 88.4 is a B, or 89.4 is a B, 89.5 is an A. No pluses or minuses, which can be really tough. So we looked to see what the A, B, C, and D, F students did, and the breakdown of resource used by the achievement levels, we looked at it for all 4 of these exams, the first instructor exam, then the common exam, the second common exam, and the second instructor exam. So now, again, I made this purposely small for you. We want to see who needs glasses. This is like an eye test. Here's the first instructor assessment. Here are the AB students, the C, and the DF. Notice that the AB students are using purple for the first instructor exam to the greatest percentage. They're using notes. So the AB students get it. It's the first instructor exam, they use the notes. The C students, pretty good. The DF students are using personal help, that's the green one, at the same level that they're using studying their notes. When you look at the last instructor exam at the end of the semester, the AB students are still using primarily notes. They are, I can see that this didn't turn out well when we put it on a different computer. Blue is prior assessment. So for the second instructor exam, the AB students are still using notes. The C students are using notes. Look at the DF student. They're not using notes at all. They're using personal help, that's the green, and they're using the multiple choice test questions for the instructor exam. So they have they're not matching it to the test anymore, and they're relying on personal help more than the other groups, and that's one of their major assessments. So where is this going? We hope to be able to say to the instructors, if someone is always coming to your class, here is probably what they're doing wrong in terms of their studying. Now let's take a look at the 6-week common exams. So again, the AB students are using the prior assessments. That's what they should do. The C students are intermediate between the AB and the DF. But look, the DF are still using personal help to a really great extent, even more than the prior exams. We get to the 12-week exam, common exam. AB students are using the prior exams. Now the C students have really jumped on that bandwagon. The DF students are using it, but they're still using personal help. Not many people are using notes. Now, are they really learning chemistry, or are they learning the test-taking skills? I mean, that is a real question for us. So our results. A, B, and C students choose more appropriate study resources for the test throughout the semester. For the instructor exams, they primarily use notes. For the common exam, they primarily use prior assessments. C students rely less on personal help and more on independent study resources as the semester progresses. DF students change to more appropriate resources as the semester progresses, slower than the other groups, but they continue to rely on personal help.
Just out of curiosity, I know the Naval Academy student body is very qualified. What's your rough A, B, C, and D percentages? Like, you can't have a DFW like we do, or you get
Right,
shot.
we don't. Right, we would be shot, yes.
So I'm just wondering, is there
We have no withdrawals, so you're not allowed to withdraw. But we do have DFs, so I think I do have the numbers for this, so I'm trying to remember it off the top of my head, so forgive me if I don't have this accurately. But the C students make up probably about 1/3, and the DF students are probably about 20%, and then the A's, when you separate out A, B's, A's are probably 20, B's are probably 30, so it's probably 20, 30, 30, 20. Because the thing you have to remember is that the way you get into the Naval Academy is not only the qualifying exams, but you have to have your senator, right? So we have to write a letter for you. So we have to have students from New York, students from Alabama, students from New Mexico. So an A student in Massachusetts may not be the same as an A student in Alabama. And I don't mean that as a derogatory thing, but there are different educational systems. So you would have kids in your class who have had AP chemistry and other students who have had 1 semester of chemistry their sophomore year in high school. And it can be that wide. And then we also have international students. So we have maybe 5 to 10% of the students will be from Ecuador or will be from Latin America who are actually enrolled in the Naval Academy. So you do have, then you have language issues. So there is a range, more than you would think.
The personal help that the DF students are getting, where are they getting that?
So we did that analysis. So we looked to see what they were using. So the C students are using mostly the instructor hours. The DF students are going someplace where they're sort of not going to be challenged. They're going to go to the midshipmen who are running sort of like a review session and they just can kind of soak up knowledge. Or they're going to the academic center where there are going to be tutors running tutoring classes where once again they can absorb knowledge. So that actually comes out in the results. So the research question, we went to the interviews. So I have some quotes dealing with how the students used prior assessment for the common exams, because we wanted to see if our interpretation of these results was right. So look at the difference between the A, B, C, and D students. The AB students say that, meaning the prior assessment, That's usually the very first thing I do when they're getting ready for a common exam, because you know what you really need to study and what you don't need to study, and I use that to direct where my studying will go. That's a good use. C students, anything I got wrong on the prior assessment, which means he or she was working it all out, I went back and I looked and I said, okay, what did I do? Where did I go wrong? What did I do wrong? And if I still didn't understand, I went and I got help from a classmate, not necessarily from a teacher. Now, the classmate could have just been closer to them when they were studying, physically closer to them. But they went for help on things they didn't understand. Also, not a bad strategy. The D student, just go through the prior exam and see if there are any huge concepts I didn't cover. Doesn't do the question. Flips through it to see, oh, there was nothing here on acid-base. I don't have to study acid-base. So actually, I had one student come into the 6-week exam, and he held the prior assessment. He said, I know how to do every problem on this prior assessment. I've gone through it. Do you think there'll be any different questions on this one? And I said, gee, you never know. Let's see. I mean, that's their mentality, that's all they have to do is to know how to do those questions. So the second research question, how do students use the study resources? So not only do they choose different things, but they use them differently. So in the literature, you'll find two uses, deep approach and surface approach. So the deep approach relates ideas, it goes for comprehension, it logically uses evidence to arrive at the answer. Surface approach, rote memorization of unrelated information, demonstrates lack of purpose, fear of failure. Fear of failure is really important. So we used a survey instrument. It was a survey instrument that was in the literature. It's called the ASSIST, A-S-S-I-S-T. We modified it because we had to change some words so that it fit with the Naval Academy. For instance, we don't call the people who teach teachers. We don't call them professors. We call them instructors because some of them are military and they're not PhDs, so they're instructors. Everyone's instructors. So we had to change some of the wording of it so that it fit. So we called it the M-ASSIST, modified assist. So we wanted to know if do student study approaches, regardless of which resource they use, differ by their achievement level in the course. So a study skills inventory was used. There are 31 questions on the M-ASSIST. 7 questions refer to the deep approach. 6 questions refer to surface approach. There were about 7 questions that refer to the strategic approach, like they're doing things because they definitely see how it's connected to helping them. At the Naval Academy, everybody was strategic, so it didn't differentiate our two groups, so we weren't able to use it. But that was probably indicative of the population we have. So here are some questions, and this is kind of a different way of graphing it. You may not have seen it before. Here are 3 of the deep approach items. Question 2, I go over the work I've done carefully to check the reasoning and that it makes sense. And they had a Likert scale. So 84% of the AB students, that's the green, either agreed or agreed somewhat. And 6% were neutral or unsure. And then you've got 11% here that disagree somewhat or disagree a lot. So looking at the trend, they go over the work they've done carefully to check it. 84% for AB, 71% for DF. That's pretty close. So everybody thinks they're doing that, or report they're doing it. Before starting work on an assignment or exam question, I think first how best to tackle it. So 78% for the AB students, 71% for the D students. Before tackling a problem or assignment, I first try to work out what lies behind it. Here we're starting to see differentiation. 63% for the AB students, down to 52% for the D students. Notice the D, F, and the C students are not all that different. So remember that, because we're going to come back to that point. So we don't see a whole lot of differentiation on the deep approach questions. They all report that they're doing it. Here's the surface approach. So here are 3 questions from the surface approach questions. Often I feel like I'm drowning in the sheer amount of material we're having to cope with. 34% of the AB students feel that way, but 79% of the DF students feel that way. 60% of the C students feel that way. Much of what I'm studying in this course makes little sense. It's like unrelated bits and pieces. 17% of AB students say it, but 61% of DF and 35% of C. I often have trouble in making sense of the things I have to remember. 29% of the AB, 74% of the DF. So the deep approach questions may not have hit home, might not have hit gold, but the surface approach questions did. So we then graphed it to get a graphical representation of it. And you look for overlap on mean plot of this. So here are the AB students on the deep questions. So you've got the AB students here who are agreeing with the deep approach questions. And there's no overlap with the DF. But notice the C students. The C students you would hope would overlap with the AB in terms of the deep approach, but they're not. They're overlapping with the DF. Now, granted, it's a more concise approach, but they're acting more like DF students than they are like AB when it comes to their use of the deep approach. Little overlap in the deep between the A and the DF. C students act more like the DF. Now we look at the surface features and we look at overlap. So you would expect the AB students not to choose the surface approach much, and they don't. You would expect the DF students to choose it a lot, and they do. And C are intermediate. Now this becomes important because this was an unexpected result, or let's say an interpretation that we hadn't planned to even look at. We now are starting to look at a C student in a different way. So have you ever had a C student come to your office before a test and they say, okay, I'm prepared for your test. I read the notes, I did all the online homework, I read the textbook, I did some extra problems, and they just rattle off everything they've done, and you say, sounds like you're in good shape. And then they come back and they've got like a 54%. And you say, well, gee, I don't know where you went wrong. It looked like you were doing the right thing. So they're probably choosing the right resources, but they're probably not using them for the deep understanding. They're probably using them more often than not on a surface approach, which means that the C students are in transition from the DF students to the AB. They're the group that we could probably target first and make have the best effect with. Where would I like to go with this research? I would like to actually use cognitive psychology approaches to study the C students to see at what point they jump from the deep approaches to the surface. Where is their lack of confidence? What doesn't work for them where scaffolding or mentoring would make a big difference? That would be where I'd want to go next. No overlap in use of surface. C students are in between AB and DF. We didn't expect to be able to categorize the C students at all. That was an added bonus for us on this research. So what did we learn? We learned that lower ability students seek help more often from resources that have a person available to them. That C students demonstrate intermediate behavior and personal help between AB and DF. The higher ability students primarily employ the deep approaches. The DF use surface features, and the C use both deep and surface. They're intermediate. When DF students come for personal help, what can I say to the faculty now? Because we reported this out to all 35. We said, okay, you're answering their immediate questions, but that's not going to help them in the long run. This is like giving a starving person a fish but not teaching them how to fish. Even if it is painful and they don't want to stay for the explanation, you've got to help them increase their metacognition, being aware of, now that's a fancy word for being aware of what they do know and what they don't. You almost have to get them to think out loud with you on that, and then you have to help them learn the meaning of the concepts. Now there's a downside to this, and the reason I bring this up is that my father-in-law was a chemistry professor at RPI, and he had 3 children, including my husband, and the kids would never go to their father for help with high school chem because it would take him 4 hours to fully explain the topic to them. So they would go anyplace else except to their father. So you do have to strike a balance when students come to your class, and that comes from reading their facial expressions and being sure that they're getting something from this discussion you're having as opposed to this lecture you're giving them. C students are in transition. So if you start to view C students this way and they come to your class and they tell you everything they've done to prepare for a test, you could do a little bit more probing about just what they're getting out of resource and how they're using it. So they should be encouraged to look beyond an answer to understanding the underlying concept, integrate the new knowledge. Integration is the key. If they don't integrate it, they will dump it after the test. So the literature will say, and we've actually done an experiment on this too, how long do students retain knowledge after a test? They will retain knowledge for the last measurement we took, which was between 1 to 2 weeks after a test, if they knew that they were going to need that knowledge for the next topic. If they didn't know they were going to need it, they actually mentally dump it within 24 hours. or I should say 48 hours. It's gone. It just, why does it take students so long to study for a final exam? Because they have to go back and relearn everything. Because they've dumped it. They didn't think they needed it. So when you're dealing with C students, you want to help them integrate, work on this integration. That's key. And to be more aware of what they know and what they don't know. Congratulate them on what they know. Push it a little further to what they maybe didn't understand. Overall results, we developed answers to questions that were important to our teachers through discipline-based research. We learned a lot more than we thought we would. We engaged teachers in thinking about classroom problems as cognitive psychology questions about how learning takes place, how different approaches to learning manifest themselves in student behavior, and what teachers can do to move students to a higher learning approach. We didn't come in and just say, we're the experts, or I didn't come in and say, I'm the expert, I'm going to tell you what to do. We sat down and we discussed together what was important to them, and we discussed together the interpretation. This was so popular, so the end result for it is that they gave posters at professional meetings on this, so it helped their professional development. It changed the way they looked at teaching. They became, in the Catholic University, were disciples of this evidence-based research. I know that'll work with the Mormons too, so I think we're okay on that. So they really understood the connection between discipline-based research and curriculum development because they were part of it. We then gave a seminar Naval Academy-wide and just told people we want to talk about the results. We had 72 people show up after the last day of class from 14 different departments. And 14 people in that 72 were from the chemistry department. Nobody was required to come. There was a lot more understanding. And those 5 people are now involved in 2 research experiments of their own design, and I'm just a spectator. They don't need me, which is really great. I've worked myself out of a job, literally. But that's how it should be. So what does chemical education research offer? More insight into how students learn, with implications about how we can better match our teaching practices to student learning. Investigation of how our resources are used by students beyond counting just the numbers. Counting doesn't do it. An experimental approach to teaching and learning that is based on data and theory. Why should chemical education research be any different from good research in chemistry, in biology, and mathematics? Good research is good research. It has to have a theoretical construct, it has to have good experimental design, and it has to be analyzed in legitimate and extensive ways. And the interpretations, may come as something new to you, the interpretations or the conclusions have to be based upon the data. That's a new thought for some people. An experimental approach to teaching and learning that's based on data and theory is not unlike traditional science approaches. So things that have worked for generations and generations do have some value when you start to look at the cognitive theory behind it. If you use an approach to teaching that was used 35 years ago and it's still working for you, then I would challenge you to look into why it's working by going after how it relates to the brain. So I'd like to thank Dr. Atwood and all members of the university for inviting me here. This has been a wonderful day, and I look forward to talking to more of you today. I'd also like to thank my research collaborators who were or are graduate students with me on the lecture article, and the USNA, which collaborators who are professors at this point, and the Kinnear Research Fund, which is what funded my ability to be there as a research professor. With that, I thank you for coming and for staying awake. You're so much better than the Naval Academy kids. And I'm more than happy to answer any questions.
Thank God. All right, questions?
Good.
Did you look at the notes the students take? Because some of my struggling students, they can take notes, but they don't know how to find information on it, so they're not useful. And so that's why they may not use them.
So Sandra McGuire, who was here as part of this, she's really good at teaching people, the techniques of note-taking. You'll find it in the literature, but Sandra makes it real. She's fantastic, and she's done it for so many times. So the Naval Academy, in answer to your direct question, is a little bit more complicated because notes mean a couple of different things at the Naval Academy. So to keep the mids awake, some professors will print out 20 pages of notes with words missing. And their notes are to stay awake long enough to put in the missing word or the missing definition. And sometimes there's also embedded in those notes, I don't mean to say that they're all horrible, are problems that the class will then stop and then do. But they love that because they walk out with a complete set of notes, so when they go to study, everything's there. So they feel very secure with that. I don't do that. A lot of other people see every version of note giving or taking across the board with 28 people. So that will be at one end. The other end will be just talking with the students, not putting anything necessarily on the board or much on the board, not doing anything with PowerPoints. So you've got everything in between. So their notes can be anything under the sun. They are given some help on note-taking by the Naval Academy, but I have not investigated that in the detail to answer your question.
I was confused by your statement early on that everybody had to graduate by order of the Secretary of the Navy, and yet you have D and F grades.
So in the summer, the Naval Academy students have 3 blocks. One block, they're on a ship after their freshman year. Another block, they're embedded with a group. And then the third block is open. So in the third block, in their freshman year, they can repeat. There's room to repeat a course. But if they use 2 summers to repeat, use that third block as a repeat, they'll fall behind. And nobody falls behind. So in 2 years, they're uninvited to the Naval Academy if they've been failing courses continually and they can't catch up.
So there is a certain amount of drop-off then from entering class to graduating class.
Yes, yes. It's very low by comparison, but I would say out of a class of 1,015, you'll probably lose 10 to 15 students during the first summer because they come into the summer. So in Maryland, summer's really hot, and they're out doing all this physical activity, and they just literally drop like flies. So what the Naval Academy did is they instituted summers in high school where they would come and they do a modified version of the summer to better prepare them to get them through that first summer. But then there will be students who are either asked to leave at the end of their sophomore year or who choose to leave. And if you leave anytime in the first 2 years, you're not responsible for paying back the tuition. If you leave after that, you have to pay back the tuition. And sometimes you can cut a deal with instead of paying back all the tuition, you volunteer to join the service for a limited number of years. It's a combination.
Lauren?
I have a question about the student population. I remember reading once, and I'm sorry I can't recall the citation, that often freshman students' grades correspond, there's a correlation between SAT scores.
Yes.
And we know that, SAT scores are correlated to socioeconomic status and other things. So I'm kind of wondering if you could look at a little larger sets of these students and kind of some of their backgrounds and what they come in with, and what kind of relationship there might be between the, in the second study, the AB, the C, and the DF students.
So we did. So we were able to access the SAT math and the SAT verbal. And in chemistry, and I can only speak to chemistry, the SAT math has, in most studies, will have a higher correlation to the result than any intervention you do. And it did here. So regardless of what resource they chose, the math SAT effect was much larger. So you could predict their achievement, not that they chose this kind, but what their math SAT was. But on the other hand, if you go to any ACS chemistry exam, or if you've gone to any exam, you can find a certain percentage can be answered with math alone without any chemistry understanding. So years ago, probably 20 years ago, I did a quick and dirty analysis of the chemistry ACS exams, and it was running about 34% to 42% of the exams were typically mathematically only. That's all you needed to answer the question. So that is, I think, the underlying reason why in chemistry the math SAT still figures in so high. The other thing that complicates this is that the best predictor of college chemistry is not the high school chemistry grade, it's the high school geometry grade. Because high school chem can be taught by memorization, but college chem is taught by logic. So the only predictor you have from high school of their ability to use logic is geometry. And that's why a lot of the students, who got A's and B's in high school chem and are getting C's and D's in college chem don't understand what's happening, but it's a completely different way of using the material. So that's kind of a long-winded answer to your result, or to your question.
Rob?
Of the clicker?
Yeah, so you did the clicker, then the 10 minutes after.
Yeah.
Do you see any smaller but any lapse? And second, as a result of that, how frequently would you recommend giving clickers in the course of the lecture?
So we did see some same kind of pattern, but it wasn't significant. It was significantly lower than the pattern of lapses in the first 10 minutes. So you can clicker the kids to death. I mean, you can't overdo it. So it actually depends. So in a 70-minute class at the Naval Academy, I would use anywhere from 3 to 5 clicker questions. And what I would do, because we had so many math problems to get through, is that I would teach them the logic and the chemistry of the problem, and then I would give them an example to work on, but the answers were in a clicker question. And then we would discuss, well, you tried it, and 30% of you got it right, 70% of you got it wrong. So now on my next slides, I'd have the question all worked out. So then we would go through it step by step. But because their ego's involved, they got it wrong. Now they want to find out why they got it wrong. I'd have them, they'd be paying attention more. Not that I measured it, but if they all got it right, or a majority got them right, and the good students hate to have to sit through something they already knew, what I would say is, 70% of you got this right according to the clicker question. So I'm not going to go through the detailed analysis, but the next 3 slides are there, and it's going to be uploaded to Blackboard. So for those of you who didn't get it right, it's all there, written out with the step and the reason. So I tried to provide both alternatives for them and use my class time a little bit more judiciously.
And then, so that's including the lecture part. What if you flipped the classroom, pulled the lecture out? Would you increase then the number of clickers?
The number of clicker questions?
Yeah.
So flipped classrooms have many different designs on them. So if your design is from what I heard last night, is that you give them some problems to do outside of class. You have them do some reading, and they have a couple of practice problems, and then you have other problems that range in difficulty and build in the class. Then you need more clicker questions, because you have to test at the levels that you're taking them through. And you want to be sure that you have an answer for, oh, you couldn't get through stage 1, so of course you couldn't get through stage 2. So that would be scaffolding built into it. So that would be using clickers as a mentoring, as a scaffolding, and you'd want to use it in smaller increments. And you probably wouldn't take quite as much time to explain each one.
Ryan? So as far as the first half goes, a lot of the research and notions that you presented are working within a fixed curriculum and how we optimize learning within that curriculum. It sounds like yours is very fixed, as to a certain degree probably our freshman chemistry is too. Has that given you any thoughts about how we might redesign the curriculum? Redesign the pacing, the format?
So yes. So as a graduate student, the most satisfying thing about being a graduate student is having access to your mentor and being involved in these discussions where you might not know where they're going to go when you start. But as you get into the graduate discussion with your advisor, you're learning by leaps and bounds, and questions that come up in that discussion, you want to go and research, because now you're really on that kind of trajectory. And you want to bring it back, and you want to argue back and forth. That is really what we want to mimic, that experience and that degree of satisfaction for each individual student sitting in a 1,000-person lecture hall. So how do we do it? So, do we get away from lecture halls altogether and do what the Naval Academy did, and no class is larger than 20? That would be great. Will the university give me enough money to hire enough instructors to do that? So there are some parameters that even if I had carte blanche to redo a course, I'm going to be stuck with some parameters that are infrastructure. So I have to learn to work with them. But I would do anything to give the students that sense of satisfaction and that give and take. And I would use technology to make a class of 500, 300 or more feel that personal. So for instance, in technology, using technology, if you put people in groups of 4, using, let's say, a POGIL approach, and you're only one instructor and you can't have any more teaching assistants and you have a class of 300, how can you use technology to make that class feel smaller? Well, there is software which will collect the results from all of the groups of 4 people in the class, and you can actually put up the results at the front of the room from the different groups that have sent them through the web to you, or you could look at them in stages, or you could preview them as you're walking around and then pick out ones that are classic problems. So people get the feel that their contribution is showing up, even if it isn't their answer all the time. So I would use technology to give that feeling and that experience to people as much as I could. But if you're going to bring about change, you can't throw the baby out with the bathwater. And in any faculty, you're going to have a range of ages and a range of experience. And you can't tell people that what they have been successful doing, depending on how you measure success, is no good. Get rid of that, and we're all doing this now. It won't work. They might go with you in name only, but they'll be lecturing. So how do you bring about hearts and minds? You start by taking whatever people are doing and get them to think about their own effectiveness and give them control how to change it. And then when people become dissatisfied with working within that narrow, if they do, that narrow range that they were able to change, then you can start the discussion about, so what if we didn't have walls on this lecture? Suppose if the lecture didn't meet face-to-face. Then you can start thinking broadly and you build support within your culture rather than telling anybody in your chemistry department that they're wrong. But see, if I was a consultant, I could do that. Oh, you're wrong, you're wrong. But within a department, you have to respect everybody and bring them all along. So does that answer your question?
Right, quick. Do you see there's any relationship between the attention lapses and the final scores people have? Is there a difference in people's ability?
Because of the IRB approval that we got, we could not ask for identity, so we didn't track the individual person. So that is so much harder to do with our IRB. But yeah, that would be great. That would be great.
All right, let's thank Diane one more time.
So I'll be around if there are other questions that you have.
And we still have a few sandwiches and drinks outside. You can get a free lunch.